Let us do combination sums when at least is present in the question. A bunch of flowers consists of a mixture of roses, tulips and daffodils. Tom orders a bunch of 7 flowers from a shop to give to a friend. There must be at least 2 of each type of flower. The shop has. You came across information, write it down. The shop has 6 roses, 5 tulips, 4 daffodils, all different from each other. Find the number of different bunches of flowers that are possible. From all this, he has to select 7. Clear? And what condition his 7 selection should satisfy is at least 2 of each type. At least 2 means 2 or more. Mathematically, how do I write greater than or equal to 2? For each the same condition. Clear so far? Okay, now I get multiple options, so I will make a table to show all the options in this way. Okay, now the number whatever I write here should satisfy this condition. The number whatever I write this condition, the number whatever I write here should satisfy this condition. And also, when I add these 3 numbers, the count has to be 7. Clear? With the condition and the count. So let us see how many such set of numbers do we get. If I start with 2, because he said at least 2. Here also 2. So 2 plus 2, 4, here it has to be 3. The count is 7 and each is satisfying the condition. Okay, now next option. This I keep it to, this I increase to 3. 2 plus 3, 5, so here it has to be 2. Only then the count will be 7. Each number satisfied the condition, so no issues. Let's continue. If I take 2 here and I increase this to 4, 2 plus 4, 6, so here it has to be 1. The count is 7, but this is not satisfying this condition. So this option you reject it. So from that what I understand is, with 2 I get only these options. Next I increase this to 3. And here at least to 2, so start with 2. 3 plus 2, 5, so here also it has to be 2, only then the count will be 7. And each satisfying the condition. So no issue with this set of numbers. Next. 3 here, increase this to 3. 3 plus 3, 6, so here it has to be 1. Only then the count will be 7. Count is 7, but 1 is not satisfying this condition. So these set of numbers reject it. Next, if I increase this to 4, here 2. 4 plus 2, 6, here it has to be 1. Count is satisfied, but 1 is not satisfying this condition. So reject this also. So from that what I understand is, I get only these options or these set of numbers satisfying the condition and the count. Clear? I gone in an organized increasing way such that no option is left out. Clear? Now let us write for each row. Here. See, from 6 different you need to select 2. That can be done in 6C2 ways. From 5 different you need to select 2. That can be done in 5C2 ways. From 4 different you need to select 3. That can be done in 4C3 ways. Clear? Now it is and between them. Whenever it is and, you need to put into sign. Clear? Same way I write for these 2 rows and I get is 6C2 into 5C3 into 4C2, and for this 6C3 into 5C2 into 4C2. Clear? Next, C1. These set of numbers satisfy the condition and the count. Accepted. Or these set of numbers satisfy the condition and the count. Or these set of numbers satisfy the condition and count. Whenever it is or, you need to add. So add these three to get the final answer, and that you should get to be 2700 is your final answer.